Hello everyone. Today's question is flood fill. So let me read the question. You are given an image represented by m cross n grid of integers image, where image of I and j represents the pixel value of image. You are also given a three integers, SR, SC, and color. Your task is to perform the flood fill on the image starting from the pixel image SR and SRC. To perform the flood fill, begin with the starting pixel width and change its color to color. Perform the same process for each pixel that is directly adjacent. Adjacent. Here adjacent means horizontal or vertically and shares the same color at the starting pixel. Keep repeating this process by checking neighboring pixel of the updated pixel and modify their color if it matches with the original color and of a starting pixel. The process stops when the color are no more adjacent pixel of the original color to update. Return modified image after performing the flood fill. Okay, so let's analyze the test case. So we are given this grid image. In this we have some values. For this test case it will be 1 and 0, and we have also given a source row and source column, so it will be 1 and 1. So the red marking is will be source cell, and we have given a color, so we can say this is a new color. We have to convert the old color, which is 1, to the new color, which is 2, and we have to convert this cell as well as it's connecting to adjacent cell, which is also a old contains old color. Like the starting cell is this and it contains 1, as we assuming that 1 is old color. Okay, a new color is 2, and old color, this cell is connected to 1, which is again old color. So we have to also fill this with a new color. We have to also fill with this new color, so it will become 2, and this is also become 2. And if we are at here, there is also connected to old color, so we also fill with a new color. So we can do this until we found a boundary, or we found a non-old color and non-new, so non-old color. So the output will be 2, 2, 2, 2, and 2. So it will be fine. And this one is not converted because this is diagonally connected. So in the question, it is mentioned that it should be horizontally connected or vertically, not diagonally. So we have to see. So there is a one edge case, like what if the new color and the old color will be same. So in this case, we just return the image, the grid itself, because we don't need to convert a new, which is because they are equal. Old color it is equal to the new color, so we don't have to worry about that. We just return that. So we will check that first. So let's start coding, and I'm going to use in this, we can use DFS, that is depth first search, and BFS, breadth first search. We can use both of them, uh, any of them. The time complexity will be same, but in this video I'm going to use BFS, which is breadth first approach. So let's see. Okay, so let me store the first of all the size of the grid. So I will store into an image dot size, and m is image of 0 dot size. Okay, now this is color is given, so it is a new color. So let me uh, remove this name. So let me rename it. This is new color. So it will be more sense, new color. And my old color is, what is the old color? Int, let me store old color equal to image of SR and SC. This is the old color. Now I have to think, is SR and SC is valid? It is valid. Let me see. SR is less than M or SC is less than it. Yeah, this is valid. So I need no need to worry about that. So uh, I will check first if old color equal to new color. So I'll return just image, given image, because we don't need to uh, fill this again because both the color are same. Now, because we are solving this problem using BFS, I'll require a queue data structure. So let me create this queue. It will be pair because I am storing cell, row, and column. Pair integer of integer, and let's name it as a queue. And also we require the direction. So if I am on it I and j, then there is a four possible direction. What are these? So let me store. It will be also vector of pair or integer, and let me name is as a directions, and this will be 1 comma 0 and 0 comma 1. Okay, how can you remember this? Like I'll write 1 comma 0 and then its opposite 0 comma 1, then I'll write minus 1 comma 0 and then its opposite it will be 0 comma minus 1. So these are the four possible directions. Okay, now I'll push the first SRC and SR and SRC for source row and source column into that SR and SC, and mark this image of SR and SC to new color, and then while queue is not empty, then what we are do, just pop out the front element. So let me name it as a row, extracting row from the front dot first and column q dot front dot second, and also pop it. So q dot pop. Now I'll go to its adjacent for auto uh, dir. Let's name it as dir of directions, and let me create a new row. New row will be row plus dir dot first, and the new column will be col plus dir dot second. Okay, now we have to validate this new row and new column. Okay, how can we do that? If new row, it should be less than n, and new column should be less than m, and new column should be greater than or equal to 0, and new row will be greater than or equal to 0, and the image of new row and new column, image of new row and new column is equal to old color. If it is old color, then we will fill with a new color. So it will be image of new color, image of new row and new column will be new color, and then we will push it into Q, because we have to process this new row and new column, its adjacent neighbor also. So let me push it, new row, new column, and that's it. After the queue is empty, I'll return image. I think I'm done. So let's try to run for the given test case and see. Okay, it is accepted. Let me try to submit this. And the time complexity will be big of, because in the worst case what happens is like all matrix is all the given grid of cell contains old color. So I have to fill the new color. I have to replace the old color with a new color. So going I will be like going all the cells. So the time complexity will be big of nm, where n is the grid row and the m is the grid column. So that's it. Thank you.